Why did old guns have such long barrels? If you look at the firearms used during the Napoleonic Wars, or the American Civil War, you'll notice one thing they all have in common. Their barrels were incredibly long. Some were over 1 meter long. Modern assault rifles, on the other hand, have barrels that are less than half that length. So why were old guns so long? Many people believe it was simply for hand-to-hand combat. And it's true that a long firearm gave soldiers a significant advantage in close combat. But that was a benefit of the long barrel, not the reason it existed. The real answer lies in the propellant and the engineering of the time. Let's begin with what happens when a gun is fired. When the trigger is pulled, the primer ignites the propellant. The propellant rapidly burns, producing hot, high-pressure gases. These gases push against the base of the bullet, accelerating it down the barrel. In other words, it isn't the flame that drives the bullet forward. It's the pressure of the expanding gases. So what's the easiest way to increase a bullet's velocity? There are only two options. The first is to use more propellant and generate higher pressure. The second is to use the pressure that's already been generated as efficiently as possible. For early firearms, the first option had serious limitations. Adding more black powder increased chamber pressure, but the steel and manufacturing techniques of the time could not safely withstand so much pressure. Making the barrel thicker was possible, but that also made the weapon much heavier and less practical for soldiers. Engineers therefore had to find another solution. They needed to achieve the desired muzzle velocity while staying within safe pressure limits. This is where barrel length becomes important. As the bullet travels forward, the volume inside the barrel increases. As that volume increases, the gas pressure gradually decreases. However, as long as pressure remains, the bullet continues to accelerate. If the barrel is too short, the bullet exits the muzzle while significant pressure still remains behind it. That remaining pressure can no longer accelerate the bullet. Instead, it's released as muzzle blast, muzzle flash, and noise. On the other hand, if the barrel is too long, the pressure eventually drops so low that it contributes very little to acceleration. Beyond that point, friction between the bullet and the barrel becomes more significant than any remaining acceleration. In other words, a longer barrel is not always better. Every cartridge and every propellant has an optimal barrel length. So why did black powder require longer barrels? Black powder is a mechanical mixture of potassium nitrate, charcoal, and sulfur. Once ignited, it burns rapidly, but unlike modern smokeless powder, its combustion characteristics cannot be precisely engineered. In addition, black powder contains less chemical energy per unit mass than smokeless powder, and a significant portion of its combustion products remains as solid residue instead of becoming gas. As a result, it is less efficient at producing the hot, expanding gases that accelerate the bullet. Because chamber pressure could not simply be increased indefinitely, engineers needed to extract as much useful work as possible from the pressure that was available. The most practical solution was to lengthen the barrel, allowing the bullet to accelerate over a greater distance before leaving the muzzle. That is the primary reason why muskets of the Napoleonic era and the American Civil War had such long barrels. Everything changed in the late 19th century with the introduction of smokeless powder. Smokeless powder contains much more chemical energy per unit mass, and nearly all of it is converted into hot gas during combustion. Even more importantly, its burning characteristics can be carefully engineered by controlling the size, shape, and surface coating of the propellant grains. Propellants designed for short barrels produce pressure quickly. Those intended for longer barrels maintain useful pressure over a greater distance. This allows modern firearms to make far more efficient use of the available pressure. As a result, today's rifles can use much shorter barrels, while producing significantly higher muzzle velocities than their historical predecessors. So the long barrels of old firearms were not primarily designed for bayonet fighting. They were the most practical engineering solution for extracting the greatest possible performance from black powder, while remaining within the safe pressure limits of the technology available at the time. The fact that those long barrels also worked well with bayonets was simply an added advantage. In the end, The shape of historical firearms was determined not by battlefield tactics alone, but by the propellant technology and engineering of their era. Thank you for watching, and see you at next video.